Hi everyone, welcome to the Yugabyte demo medley, where over the course of the next hour, we will be featuring three awesome Yugabyte product demos by our field engineering team. This is a no filler session, so let's get started. The first demo is Cloud Native Resilience with Yugabyte Platform and the YSQL Smart Driver by Andrius Markvaldas and Eric Pratt.
Hi, everyone. Welcome to YugabyteDB's Distributed SQL Summit. My name is Andrius Markvaldas. I'm a principal pre-sales engineer for Yugabyte based in Chicago. And today I'm going to be talking about geo-resiliency and our smart driver technology for client applications. But before I go any further, I'd like to give a moment to let my counterpart introduce himself.
Hi, everyone. My name is Eric Pratt. I'm a senior solutions engineer here at Yugabyte. I also live in the Denver metro area, and I'm looking forward to this presentation.
Great, Eric. Thanks. So we only have 20 minutes and we have quite a bit to cover. So in terms of an agenda today, I'm just going to be briefly talking about what YugabyteDB is and our PostgreSQL and Cassandra API capabilities. Additionally, I'm going to talk about combining our client driver technologies with the YugabyteDB database platform, how you can build applications that are not only fault tolerant and topology aware, but also load balance across your ecosystem. And then finally, using our platform, I'm going to build out a multi-region Yugabyte universe, start a couple clients that have been built with our client drivers, and then simulate a regional outage and show and demonstrate how resilient our architecture is. And then finally, if we have a little bit of time left over, I'm going to kick off an upgrade of our software and show how you can upgrade our software and not encourage an outage penalty and have a completely resilient ecosystem and architecture for your applications. So what exactly is YugabyteDB? It's a transactionally distributed SQL database that's designed for resilience and scale. And it was inspired by Google Spanner. It's 100% open source. It's an enterprise-grade database system. And most importantly, it's built to run across all your cloud environments, whether they're provided by a vendor or in your on-premise data center, leveraging physical virtual machines, or even container orchestration applications such as Kubernetes. Regardless on the deployment, you have a completely distributed and transactional data fabric for your application ecosystem that is not only Postgres, but also Cassandra API compatible. So what is our definition of distributed SQL? First, it has to be a fully relational SQL API that enables you to do distributed query execution and have complete ACID transaction capabilities. It rests on a distributed resilient data storage layer, but probably most importantly, it's strongly consistent and synchronously replicates all the data across all the nodes in your data fabric. Meaning that if you've ever deployed an active replication strategy using some of the legacy software or database platforms that are out there right now, you'll know that it's very difficult to plan and deploy one of these types of architectures into production. And once it's there, it's even harder to maintain. Using YugabyteDB, you get a strongly synchronous replicated environment, and we try to take all the lead work and make it easy for you to maintain. And how do we do that? And so it starts with a layered architecture. We've customized a RocksDB storage engine for our distributed document store. And the reason why we chose RocksDB is first, it has strong write consistently. And then secondly, it's extremely resilient to failure. We use the RAF consensus protocol to maintain the ecosystem. And we do all the sharding and load balancing for you at the storage layer. And then finally, every single insert that's occurring into our ecosystem, it's both zone, region, and cloud aware in its placement of the data. So you get a fully distributed storage environment that our query layer then can rest on top of. And right from the beginning, we had a Cassandra compatible API. So if you had an application that needed blazingly fast query performance and was ingesting massive amounts of data, Yugabyte was a very easy choice for you to choose as a backend. And then fairly recently, we've also introduced a Postgres compatible API. So if you have an ANSI SQL OLTP engine that is powering your application, and you need the ability to have it horizontally scale or geographically distribute the data for performance reasons, again, Yugabyte is a great choice for your database platform. So Eric, do you want to talk a little bit about our YSQL enhancements?
So, in addition to our, YSQL API, we added some enhancements that kind of go above and beyond your normal Cassandra workloads. So those are native JSON support. We have geographic location hints, which I think is pretty important. But the big one that I like is our strongly consistent secondary indexes. And anyone that's worked with Cassandra before knows that you can struggle a little bit with indexes being not consistent or maybe have a lot of tombstones and such. So, that portion of our API, I think, is really important because, unlike when I worked back in Cassandra, oftentimes I would say, maybe don't want that secondary index, or you shouldn't have too many. Here, we welcome them. We want your secondary indexes. So I think that's an important distinction between us. But the star of the show, I think, is our smart driver for YSQL that we're going to demonstrate today.
Great, thanks, Eric. So just jumping back quickly before we get into the client driver overview, I'm just going to quickly touch on what YSQL is. So it's really our Postgres SQL compatible API for relational workloads. So as I mentioned earlier, if you've designed an application for a single database and you need to actually distribute it, YugabyteDB is an excellent choice for that type of workload. Because we've essentially taken the top half of Postgres and modified it to work with our storage engine, it fully supports primary keys, foreign key relationships. You can do joins, you can have distributed transactions. And in some ways, sometimes the biggest hang up for migrations is actually being able to migrate over those triggers and stored procedures that your applications are using and keeping them in the database, as opposed to having to migrate to another platform and actually having to bring them into the application. Additionally, we also support some Postgres extensions as well. So in essence, if it works in Postgres, it will work in YugabyteDB. We support serializable and snapshot isolation. We're compatible with the 11.2 version and soon to be upgrading as well. And like Google Spanner, YugabyteDB is considered a CP-based database, so it's consistent and partition tolerant. So in addition to the Cassandra driver, we also just recently introduced a JDBC smart driver for Yugabyte. Originally, you would just leverage the JDBC driver that Postgres provided for you to connect and run your application against the Yugabyte backend. That taking some of the cues from our Cassandra driver, we wanted to make a driver that was not only cluster aware, but also aware of the topology of the cluster. So now you can build your applications using our JDBC smart driver to go against the YugabyteDB platform and have that capability. And some of the things on our roadmap that we want to also implement in this driver is shard awareness. But we're going to demonstrate those capabilities in just a couple of minutes when we spin up a cluster and actually kick off a couple of applications. And finally, I just want to briefly touch on really our geo-distribution with synchronous replication capabilities. You really have a multiple array of choices when you're deploying a YugabyteDB in your ecosystem. You can choose something that's just consistent across availability zones in a single region or data center. However, you could start building on that where you could actually have a single cloud deployment, except it could be a region. In essence, you have a cross-region WAN where really the thing that you really have to start thinking about more is the latency of the application as opposed to the resiliency of it. And then finally, there's a lot of architectures out there that need to have a hybrid cloud or hybrid cloud / on-premise type of deployment. With YugabyteDB, you have that capability of deploying not into a multi-vendor cloud environment, but you could also start out by leveraging your on-premise data centers and then add capabilities into the cloud, making the migrations of your application to the cloud a lot easier, a lot safer, and in some ways even having the ability to roll back. So out of the box, you get this geo-distributed database capability with Yugabyte. So just to quickly touch on how our demo is going to be working today, we're going to, again, be talking, I'm going to be setting up a multi-regional universe for Yugabyte. I'm just going to be using our AWS platform. The nodes aren't going to be very big, 8 core, 16 gig. But again, most importantly, this is going to be a multi-regional environment. And I'm going to start up a couple applications, and then I'm going to simulate an outage. I'm just going to really just hard cut out the US region, and then we're going to see what happens. So let's go and fire up the platform and fire up a universe. So as you can see here, we're actually going against one of our Yugabyte platforms here that our development and engineering uses to build out and test releases. And the thing that I want to point out really quickly first, again, and stress, is that you really have the capability of almost an endless array of choices in terms of deploying and configuring your Yugabyte environment. In this particular case, we're going to be using the Amazon Web Services architecture. However, we fully support GCP, Azure. If you have a Kubernetes service or even an on-premise data center, you could very easily configure a Yugabyte cluster to leverage those ecosystems and build out a completely resilient and distributed data fabric. And
one thing I kind of jump in here is you notice we have one platform with multiple universes. So you can have one orchestration center for all of your databases that you have. If you have multiple applications running data against different, needs different separation of their database, we have that here for you in one spot.
Yeah, and I'll be actually going against this AWS configuration where we configured an ecosystem, and I can deploy nodes to any one of these AWS regions. And let me just show you how easy it is to get something up and going. And so I'm just going to name this. I'm going to pick the portal that we just did. And as I mentioned, I'm just going to keep this US based. I'm going to pick US East 1, 2, and then I'm going to pick West 2. Now, the nice thing here, I'm just going to create a 3-node cluster, but you have the flexibility to make these as large and as small and place these nodes in whatever availability zone is available and configured for this region. I'm using a replication factor of 3, but you could easily change that to 5 or even 7. But for simplicity's sake, I'm going to just keep it at 3. I could also change the size and make these much larger. We actually have customers that are sometimes are able to really scale down their Cassandra deployments in their ecosystems using a lot less hardware, because we can actually be a lot more, we could pack a lot more density on each one of these instances. And then finally, I know with cloud, encryption and security is very important. All the communication between our database servers can be fully encrypted, as well as we're using TLS 1.2 between the client and the database. I could also encrypt the database at rest on the instances and use a key management service that's provided in AWS. Finally, I can pick any one of these instances or releases of Yugabyte. And in this particular case, I'm going to pick an old one so I could show an upgrade of the software before releasing it. And I think that's about it. So I'm just going to click create. Oh, let me just turn that off. And now we're off and running. So it takes a little bit of time for AWS to spin up these instances and copy down the containers to run this. So I'm going to switch to an environment that I've already set up here, and then switch over and kick off some of the clients that are going against the platform. So I'm actually going to simulate two different types of application. The first one is our Cassandra workload using our Cassandra driver. And if you notice, these are just simple applications that create a table and are just spinning up a bunch of read and write threads. And the thing to point out here is that I'm actually just using one node when I'm putting it into this driver. And as you can see, when the setup is being created, the driver itself is topology as well as cluster aware. So it actually connects to all four of these drivers, and it's doing read and write operations. On the Postgres SQL side, I'm going to kick off essentially a SQL insert, a read and write type of scenario, again, about 100 threads. And as you could see here, again, I've only put in one IP address for my cluster, but we built into the smart driver the ability to get a list of private or public servers, depending on your configuration. As you could see here, it's listed out all the IP addresses of the 3-node cluster that I've created. And then it's also running some functions to actually get the least loaded server to start actually loading data into the system. So as you could see here on our Cassandra API, we're doing about 20 milliseconds per operation, about 2,500 ops per second on reads, about 850 on the writes. And you would expect, again, the Postgres, because it's fully ANSI compliant, it's also has ACID capabilities. With the commits and all the other operations that need to occur on a OLTP system, you'd expect a little bit less performance in terms of the reads, but we're still getting about 700 operations per second and about 450 writes. And all this is about 200 threads hitting the Yugabyte cluster. So let's go back and just take a look at and refresh the page here and kind of see what's going on with the cluster. And as you can see, 200 threads, we're barely even cracking the CPU. We have a lot of capabilities here, and to look into the ecosystem, as you can see, there's I have the Northwinds database with multiple tables. Here's our Cassandra key value and Postgres SQL key value tables that we created on the fly. You have visibility again into the nodes that we created. Again, US West 2, East 1, East 2, and you could actually even see the queries. You have the capability of seeing the queries, and as you can see, we're doing a bunch of inserts and selects into the ecosystem. So let's go back and go ahead, Eric.
I was going to say, yeah, I just want to stress, we're running both of these against the same database, right? Cassandra and YSQL. Without a load balancer, it already knows what it's doing. It is so cool. And we have about 1:30, so let's go ahead and kick out legs from one of the nodes.
Yep. Yeah, and just to stress the whole load balanced approach. If you remember, I just connected to the actually this particular client is actually running in US East 2. and I connected to this node. And as you can see, the read-write operations are fully distributed evenly across our ecosystem. So let's connect to the west and just take it out and see kind of what happens. So I'm just gonna select it. I'm gonna go to instance state. I'm gonna stop the instance. And let's take a look at what happens. So you see a couple errors going on here in the YSQL driver. That's actually, there's actually a primary key defined on the table, and some of the threads on this hard cutover are trying to insert duplicates and we're getting kicked out. And as you can see though, on the Cassandra, it just kind of keeps on ticking. And the thing that I also want to point out, and I mentioned this a little bit earlier in our presentation, was that the show is really dictated on network latency. And since we actually took out the Western region, we are able to actually improve our read and write performance because we don't have to span and go out to the West Coast to actually do these reads and writes. And as you can see, this thing has stayed up and is performing even better than before. And if we bring it back up, it'll go back to normal. The only other thing I just wanted to very quickly point out is to upgrade the software. I know we're pretty much at time. It's as easy as just clicking that, picking an instance, and hitting upgrade. So I think, Eric, do you have any other final thoughts before we close this out?
No, it's I think it's a cool demo. Look forward to seeing you guys on our community Slack. Check us out on GitHub. All of us are there. Our founders are on the community Slack. You can talk to us anytime.
Yeah, and I wish everyone a great conference, and I encourage everyone to attend other sessions. There's a lot of great material out there. Thanks a lot, and I appreciate your time.
Hey, you beings. Hope you've enjoyed our workshop day so far. Already been some great sessions, and there's still a ton more to come. For this workshop, we'll be going over how to do a live migration from MySQL to Yugabyte using Blitz.io. Before starting, we'll do a quick intro. My name's Taylor. I've been working at Yugabyte for just over a year, and I'm currently leading the sales engineering team for our new cloud product. Before that, I worked on the enterprise sales engineering team, where I helped Fortune 500 companies install, migrate, and adopt Yugabyte. Before working at Yugabyte, I worked at DataStax, which deployed enterprise-grade Cassandra for companies across the globe. As you can see by the little buffalo picture at the bottom there, I'm a proud CU Buff alum. Joining me is Mark Jeske, who is a senior sales engineer at Yugabyte, working with a number of enterprise customers. Previously, he had experience at Informix, Netezza, and Yellowbrick, helping customers deploy MPP database systems for both data warehouse and transaction workloads, both on-premise and in the cloud. So before even starting migration, the first thing any developer or DBA should do is have a good understanding of where their current pain points are in their current database, and then choose a database that services those needs. When choosing a database like Yugabyte, we tend to see people move for a variety of reasons, but I want to touch on some of the major ones. The first is having the need to have a geo-distributed database. In the world we live in now, data is everywhere. It needs to be accessed from anywhere with maximum performance. Yugabyte has a plethora of options to handle this, including synchronous, asynchronous, and geo-partition data that can get data closer to your users. Another big reason we see people move to Yugabyte is to have the ability to horizontally scale with ease. With most classic RDBMS databases, you can only scale up, and we'll get to a point where you just can't vertically scale anymore. And at that point, you have to make some difficult decisions on how you're going to continue growing, like manually partitioning the data, which is not a trivial process to undertake. With Yugabyte, we can horizontally scale endlessly, so that way you no longer have to worry about hitting that scale wall again. Another huge reason why we see people move to Yugabyte is for our high availability. In many normal RDBMS databases, having a plan for disaster recovery is crucial, and many times the only option is to have an active passive setup, where if an active cluster dies, you have to flip over to a passive cluster, which take minutes to do. With Yugabyte, losing a node, an AZ, or even a region is not a big deal, as we are able to be natively geographically redundant. The last reason is not necessarily a driving reason people move to Yugabyte, but it's something that we constantly see customers that ends up being a huge plus. Yugabyte is a Postgres compatible database, which means anyone who has used it or is currently using it for their DB will find migrating to Yugabyte a breeze. It's just a simple lift and shift of the database, and you have yourself a highly available, geo-distributed, and database that can scale infinitely. Now that we know why we want to move, it's important to understand some of the headaches and gotchas that go along with migrations. The first one that always comes up is how do you go about migrating the schema? For some migrations like Postgres or Cassandra to Yugabyte, this is a very simple thing to do. But for other databases like Oracle SQL Server, it can be notoriously difficult to do. Then there is the issue with data coming in so fast and at such a high volume that trying to then migrate the incoming data and pre-existing data at the same time can cause systems to literally fall over. We also have options in how we can do migrations, whether it be in a snapshot where you end up taking some downtime, or it could be an incremental approach. But in each case, there could be a time when the new database is behind, or you would have to take a major maintenance window, which may not be acceptable for your application. Then what if the worst happens and during the migration, there's a failure of some kind or a DDL change? Would that mean you'd have to start from scratch? All of these challenges give DBAs and developers migraines and many sleepless nights. Think about which is why Yugabyte, we create a fantastic partnership with Blitz.io in order to take care of all of these challenges. So what is Blitz? Blitz is a cloud-native data replication platform that migrates data from one database to another by autonomously migrating schemas and continuously replicating data across non-uniform databases. It was built from scratch to handle those high volume and high velocity use cases, and Blitz is 100% autonomous, distributed, and fault tolerant, allowing for simple and streamlined migrations. So here's some of the key features of Blitz. First, it automatically takes care of migrating the schema for you. No longer do you have to sit and try to figure out how to make a square peg fit into a round hole. Blitz.io will take those Oracle databases and automatically do the schema migration. It has bidirectional replication as well as automatic recovery and checkpoints. So if the worst does happen and a failure occurs, you no longer need to worry about starting from scratch. Blitz.io also has flexible migration options, whether you want to do a snapshot or live migration using its CDC functionality. And importantly, it has built-in data encryption. So you have the confidence that while your data is moving across databases, there's no way it can be maliciously accessed and used. Blitz offers two different licenses. First is the developer license, which offers you schema migrations, snapshot, and live migrations. Lag reporting, so that you can have visibility into whether or not it's able to keep up with those high volume situations. Fault tolerance, so you can be less concerned about having to start over, and it can be used to migrate data from any open source database. The other license is their enterprise license, which has all the features I just mentioned, but also includes additional monitoring so that you have a better idea of what and where it is at in the migration process. And it allows you to do migrations from databases that are closed source like Oracle. Here's a list of supported DBs that Blitz can work with. And as you can see, there's dozens of databases that it works with. And with that, I'll hand this over to Mark so he could show you how to do a live migration from MySQL to Yugabyte. Mark, it's all yours.
All right, thanks, Taylor. So what I want to show you today is just a quick demonstration of a tool that Taylor was just describing called Blitz that we use to perform migrations from a source database, could be anything, Oracle, Teradata, SQL Server, MySQL. For this example, I'm going to use MySQL, and then we're going to migrate data from a couple tables in a MySQL database over into a Yugabyte universe. So what I'm showing you here on the screen is just the overview screen of a cluster that I've created in Yugabyte Cloud that I'm going to be using for the demonstration. And then all the software I'm going to run, the MySQL and the Blitz, is just running on a 4 CPU instance node in GCP that you can see there in the GCP console. Okay. So to actually run the demonstration, I have 4 terminal windows here that I'm going to use. On the left, this yellow window is going to be where I'll run the MySQL commands. The blue window here in the middle is where I'll run Blitz. And then correspondingly, the green window here over on the right is where I'll run the Yugabyte commands to show you the changes there. So to start with, I just got a number of scripts in the directory I'll be using here. The first thing we want to do is just run this YB reset to just drop and create our database in Yugabyte. And there we go. Okay, so we have an empty database here. If I go back to the Yugabyte Cloud console, I go to tables, you'll see that I have no tables there just to verify that the database is empty. Okay. Now, if I go over to my MySQL side, I can run the same script, MySQL reset.sh. This just goes in and drops the tables on the MySQL side, recreates them. It only populates 2 of the tables. I'm using the schema from TPCC benchmark, so there's 7 or 8 tables in there. And so I've recreated all those tables, but I only put rows in orders and order line, as you can see there, 10,000 rows and 50,000 rows correspondingly. Okay. And then what I'll do here is I'm going to start a script on the Yugabyte side, YBWatch, which does nothing more than loops around every 2 or 3 seconds, and then does a select count star on the 2 tables that we're going to migrate. So they don't exist now, of course, so I just get an error. So we'll just leave that running over there. Okay. So up in the blue window is where I'll run blitz. The command I'm going to run is blitz full.sh. So this does a full replication. The command line is actually called replicant. I'm doing a full replication. There are a number of config files here, YAML files that describe the sources, the target, what tables you want to migrate. There are different options for extracting and filtering and so on. Okay, so let me just briefly show you the YAML files, and we can take a look at the MySQL.yaml, which is just the connection side for MySQL as an example. And that's as simple as you need. You just give it the IP address, the port, your login, and so on. And then if I look at my filter file here, this is where I describe what tables and databases I actually want to migrate. And again, in this example, I'm just using the database called migrate demo, but I've restricted it to only these 2 tables, even though on my MySQL side, I have a number of tables. So if I show you that over here, I'm going to show tables. You'll see I have all these tables defined, but I'm only going to migrate those 2. Okay. All right. So let me run the blitz full command here, and we'll start the migration. So the first thing blitz does, it connects to the source, MySQL in this case. It goes, hey, those objects don't exist on the Yugabyte side, so it creates them. So now you can see there's the orders table, there's the orders line table suddenly appeared, and it's moved all the existing data over. And now it's essentially sitting in real-time mode where it's simply reading the CDC log on the MySQL side, waiting for activity to show up so it can migrate that activity over to the Yugabyte side. Okay. So let me stop the YBWatch over here real quick and go into the command line here and just look at the tables that were created. So now we have 2 tables, we have 2 sequences, and let me just describe one of those, the orders table as an example. And I'll do the corresponding on the MySQL side. So describe table orders. Describe table orders. Again. How about describe orders? There we go. You can see I don't use MySQL that often. Okay, so we have a number of columns here, the corresponding type that was created on the Yugabyte side. And then the reason we created the sequence was to handle the auto increment from the MySQL side. So on the Yugabyte side, we created a sequence for that to handle the auto increment column. The nice thing, of course, here is I didn't have to sit here and figure out all the column types or go through all the drudgery of moving the DDL over. Blitz did all of that for me. Okay. So let me reset here, get the watch going so we can see rows show up. So at this point, we actually want to add a load to the MySQL side so we can watch the data flow through the Blitz interface. So again, I have a script here, MySQL gen.sh, which does nothing more than sit here and sits in a loop. Every 1 second, it inserts 1,000 rows in each of the 2 tables. So logically, this insert statement makes no sense. I'm just using it to generate a load, but it inserts 1,000 rows by selecting 1,000 rows out of the same table. Okay, so insert into orders, select 1,000 rows from orders, and the same thing for the order line table. Okay, so let me start that up. Go. Okay. Now what you'll see here, of course, is that the rows are increasing on the MySQL side. You'll see the Blitz interface changing as it recognizes those rows, inserts them over the Yugabyte side. And of course, on the Yugabyte side, you'll see the row count increasing. So right now the data is flowing from MySQL and the Yugabyte via Blitz. Okay. Now, one column to kind of keep track of here on the Blitz side is this lag column, which is the number of milliseconds from when a row is inserted on the MySQL side until Blitz has inserted it onto the Yugabyte side. So in this case, the lag is fairly consistent. It's in this 1 to 1.5 second range, depending on your load and timing and so on. Now, one thing to keep track of is if for whatever reason Blitz can't keep up with the load, that lag will slowly increase. And then for whatever reason, if the load lowers on the MySQL side, the lag will drop back down as it essentially catches up in moving rows over to the Yugabyte side. And there are a number of ways to configure Blitz for that kind of scenario where you're not keeping up with the load. You can run Blitz on multiple clusters or nodes. You can separate tables out into different instances of Blitz. You can configure number of connections and threads. There's all kinds of techniques to make sure that it can keep up with the load as appropriate for your source system. So real quickly over here, let's just jump back into the Yugabyte Cloud interface. We'll refresh the metrics. And so here you can see the load that we're generating on the metric screen for the YB Cloud instance. And those reads that you see there are simply the count stars that I'm running in the green window, and then the corresponding writes for the inserts that Blitz is doing into Yugabyte. Okay. Now, one thing you have to be aware of here is if for any reason your replication with Blitz gets interrupted, potentially the node fails, maybe you have a network problem, whatever, there is a way to simply restart Blitz and do what they call a resume and have it pick up where it left off. So let me just simulate that for you real quick here. So I'm just going to go up to the blue window. I'm going to do a Control-C. So I've stopped Blitz. This is my interruption for whatever reason. And then I have a resume script here. Now, the resume is exactly what I ran before. The same command, full replication, same set of config files. I've just added a flag here, -- resume, to say, hey, restart from where you left off, but don't start fresh, assume all the objects are there and so on. Okay, so let me just run that. Blitz will restart. It'll start to move rows over again from MySQL to Yugabyte. And what you'll see here in a second is the lag will jump up fairly high, probably 40 or 50 seconds. There we go, 45 seconds. That's essentially the length of time that I had Blitz stopped. Right, if that had been 5 minutes or 30 minutes or an hour, you would just see a lag jump up to kind of that time frame. Now here, because I can apply the rows faster on the Yugabyte side than they're arriving on the MySQL side, you see that lag slowly drop down. So where we were at that 45 seconds is slowly dropping as essentially Blitz is catching up. And we'll be back to essentially the 1.5 second range, kind of the steady state that we were before. There we go. So we've essentially caught up now. We're steady state back to where we were. And then if we go over here and just check our cloud interface again, just let's look at the metrics. And there's the workload essentially running and catching up. Okay. So at this point, it's very simple to do a migration. You simply use Blitz to get the data moving. You run it for whatever amount of time you need for your environment to move over. It could be a couple hours, could be a day or a week till you're confident the data is over on the Yugabyte side. And then essentially all you need to complete your migration is you simply stop the load on your source. So in this case, I stopped it on the MySQL side. You wait for your lag to drop down until there's no more activity. So it's caught up and it's moved all the data now over to your Yugabyte side. And then you would simply take your clients and point them to Yugabyte and restart them. And away you go. So you can kind of do this flash cutover of a few seconds or a minute or so. And now you've moved all your workload over from your source system into Yugabyte. Thanks for your time. If you have any questions, please put questions in the chat window. Thanks.
Hey folks, welcome to Distributed SQL Summit 2021. We have an amazing demo that we'll be presenting to you today. It's basically taking Yugabyte distributed SQL database running on top of Google Anthos. And for this demo today, we have 3 separate Google Anthos deployed in 3 regions where you'll have a single Yugabyte cluster deployed on top of it. So before we begin, we wanted to quickly introduce ourselves. So my name is Amay Banarse. I lead the field team here in Yugabyte. So essentially a team of customer-facing engineers who help our customers day-to-day with database modernization, helping them with best practices when it comes to Yugabyte, or helping them with legacy Oracle or MySQL to Yugabyte migrations as well. So we do that end-to-end data pipelining thing for our customers. We also have Jake on the call today. Jake's basically gonna walk us through the technical architecture and the demo of this whole thing. Jake, do you want to quickly introduce yourselves?
Hi, everyone. I'm Jake Angerman. I'm a pre-sales architect here at Yugabyte.
Thanks, Jake. So folks, the way we wanted to put this together was give you a quick view into like, why is Kubernetes so massively popular? What does Yugabyte bring to the table when it comes to deploying on top of Kubernetes? And then essentially walking you through the entire Yugabyte running on Google Anthos. So to kickstart that, we just wanted to highlight that Kubernetes is actually massively popular in Fortune 500s. And you shouldn't take our word for it. And that's why we brought these 3 case studies in front of you, wherein first thing was Walmart, which was essentially modernizing their entire application stack to become more cloud native. And in that process, they wanted to eliminate any network or network related latencies that comes from the stores to the data centers. So they started doing edge computing and leveraging Kubernetes as a runtime substrate to do that in a very cloud native way. It's an amazing case study. We have put in a link here so that you folks can go ahead and watch it. The second one that we thought would be really useful for all of us would be how Target, as yet another retailer in this case study here, does stateful workloads like Cassandra on top of their 1,800 stores. So that is 1,800 stores run a small Kubernetes cluster, and they run Cassandra deployment and set of microservices apps in each of those clusters. And they essentially have this whole thing completely automatically deployed. So it's an amazing case study to see how Target and giants retailers like Target are leveraging Kubernetes for ensuring a really seamless user experience. And then the third one, which most of us would be using in some form or fashion, is the company called Box, which provides you the enterprise storage and enterprise content management as a service. Essentially, Box started looking at Kubernetes for that seamless user experience as well. But more importantly, when Box was going through a cloud-native digital transformation, they chose to use Kubernetes for doing that, as opposed to building their own data centers or virtual machine-based deployments. So it's amazing to see that some of these really massively popular enterprises are starting to use Kubernetes, and they're using it in production since like last few years now. And when you look at some of the insights that are gathered by, in this case, by VMware, that is how exactly enterprises are embracing Kubernetes, we quickly take a look at like the substantial growth that Kubernetes has achieved. That is, a lot of enterprises actually run 5,000 plus containers at any given time in production. That's a pretty massive scale, considering Kubernetes is just 6 to 7 year olds at this point. The second thing is that on-prem data center deployments are still very relevant here. Essentially, customers would like to still use their investments that they have done in the on-prem data centers, and at times have on-prem plus either of the cloud providers achieve that whole resilience and HA for you as well. And even though Kubernetes is still maturing, and there are certain pain points, whichever comes with the maturity curve of any new technology, everyone in the executive level feels that Kubernetes is worth the investment. That is, it's an important element to everything that provides a seamless customer service or customer experience to your end customers with cloud native CI/CD and digital transformation overall. Now, when we look at what it really takes to run a data or database or any data framework on top of Kubernetes, there are actually a lot of players in this field, and just some logos that we have put in here. And these are some of the companies and vendors who have taken their core projects, like databases in our case, or Kafka in case of Confluent, or Apache Spark in case of Databricks and the Apache Spark community itself. They have essentially taken done the efforts to making sure that they leverage the entire set of constructs given by Kubernetes to ensure a really robust and automated deployment of some of these frameworks and databases in general. And there are a lot of learnings from these. That is, it's not super easy to just take a legacy database, put it in container, and run it on Kubernetes. You have to really embrace what Kubernetes provides you in terms of stateful sets and deployments, and making sure that you package it correctly. And those are the things that we're going to see today, how Yugabyte does it, and essentially how we apply it to a runtime like Google Anthos. So that being said, we as in Yugabyte have our founding roots from Facebook. That is, our founding team actually created Cassandra and Postgres inside Facebook. And this time, our mission with Yugabyte is to make sure that we can provide you a transactional, strongly consistent database, which can be deployed across any form factor, that is virtual machines, bare metals, or Kubernetes, or containers of any point. And at the same time, take care of some of the pain points that legacy databases had in terms of providing HA and resilience, but built into the single database architecture itself. So that's what we do at Yugabyte. This is how our Yugabyte architecture is today. That is, we are very much inspired by Google Spanner when it comes to the storage layer of the architecture. That is, we leverage RocksDB and we optimize it to become a key to a document store. And using that in combination with Raft as a consensus protocol, we essentially give you an ACID compliant transactionally distributed database on the lower half. Now on the upper half, we give you 100% Postgres 11.2 compatible API on top of it, and also a Cassandra API for your NoSQL semi-relational style workloads as well. Now that being said, we take care of horizontal scalability, distributed transactions, and data replication built into the architecture of Yugabyte itself. So you don't have to worry about any other replication technology when you want to deploy Yugabyte on top of multiple data centers in multiple different regions. Yugabyte is strongly consistent in those things and takes care of data resiliency and data HA on multi-geographical deployments. Now, what does it really take for a distributed SQL database like Yugabyte to run on, let's say, Kubernetes? Or in this case, we can just say any CNCF certified Kubernetes. So first thing is that on the left-hand side, you see all the highlights. That is everything that Kubernetes provides as a core concept to any data service that runs on top of Kubernetes. That is better resource utilization, automated D2 operations. It takes care of orchestration and portability across multiple clouds. It does it perfectly. But there are certain operational maturities that are still in the works when it comes to Kubernetes. And some of the very important things for a stateful application like Yugabyte would be a need for load balancer. And the load balancer construct itself changes from every single cloud provider or every single data center that you deploy on top of. So it's very important to understand what kind of load balancers are available if you want external applications connecting to a distributed SQL database like Yugabyte. There are a few operational challenges when it comes to like networking across multiple regions, across multiple Kubernetes clusters. A variety of CNI technologies exist for that. And those are some of the things that we can explore in today's conversation and demo as well. In terms of deployment itself, so Yugabyte engineering team adopts and essentially embraces all the constructs given to us from Kubernetes APIs only. So essentially, Yugabyte gets deployed as stateful sets. So in this case, a simplest topology of Yugabyte would be two different stateful sets, one for the master service, which is like a lightweight metadata service, which keeps track of the cluster health and cluster overall cluster state in Yugabyte. And then the second stateful set would be the tablet servers, which would actually hold the data and would serve as a read and write layer for your applications when they are storing data in Yugabyte. So for us, you deploy a master stateful set with odd number of failure domains that are available in your data centers. And tablet server stateful set can scale up from 3 to infinite in that case, depending on the capacity you have in your Kubernetes clusters. This can either be deployed through Helm chart, or you can leverage Kubernetes operator to deploy this and automate a whole bunch of data operations with it as well. That is, Yugabyte itself provides you a way to handle failures. That is, tapping into Kubernetes' way of handling failures and pod resurrection. Yugabyte essentially can have a pod or two go down at a time, take care of redirecting it and rebalancing the data when the pod becomes available. Or you can do rolling upgrades with no downtime. That is, the logic for rolling upgrades in canary style of one is built into Yugabyte algorithms and Yugabyte's whole cluster management itself. And these are very hard things to do in a legacy database that just works easily with combination of Yugabyte running on top of Kubernetes. And there are other things like backup restore. So Yugabyte supports fully transactional backup and restore to any object store or NFS volumes. That is done through Yugabyte code itself without having any dependency on external backup restore vendors or providers. We also support point-in-time recovery. That is the latest feature that we built into the product about 3 months ago, and essentially allows you to go back in time and restore the database to that state that you want it to be, like let's say a few hours ago or a day ago. And this essentially helps you with any accidental deletes or drops of the tables. Let's say if there's a developer who accidentally deleted a table, you can go back in time and restore the database at that point in time. Now, that being said, I'm going to hand it over to Jake today, who's going to walk us through what is Google Anthos and how we are doing a Yugabyte on top of Google Anthos demo. So Jake, over to you.
All right. Thanks, Amay. Go forward one slide. So let's talk about what Google Anthos is. What it gives you as a DevOps person is the ability to modernize your application stack. It allows you to deploy things in a consistent manner across different types of infrastructure without really caring whether you're a developer or an operations person, how that gets deployed. So what that allows you to do is you can write an application, you can do it simply and deploy it in a manner, whether it's on-prem, whether it's on Google Cloud or some other cloud, in a manner that you abstract away, how you actually deploy that, and you're more focused on the application and modernizing your application than you are about where it's running. So that's great from a developer perspective and from an operations perspective as well. What does it take to get YugabyteDB to run on Anthos and multi-region deployments? Well, you need to have the ability for the different GKE clusters to communicate with each other via TCP. You need to have a global DNS resolution system so that whatever cluster you're in, you can talk to the other clusters. And that's why I have my favorite DevOps haiku over on the right there about how important DNS is. And then you need to be able to create load balancers and have the correct role-based access control to do a cluster role and a cluster role binding. So if you have those pieces together, you're able to deploy Yugabyte on Anthos. So in a multi-region configuration, what does YugabyteDB give you? It gives you the ability to deploy a database in a manner that gives you the scalability and high availability and business continuity to deploy your application in a geo-distributed model. And you can also take that one step further and actually have geo-partitioning, so that if you wanted to, you could have data that is pertinent or needs to remain in a certain geography or region to stay in that particular region and have segments basically between the different data sets. So what I'm going to show you today is an application called Bank of Anthos. It's an open source application. You can find it on GitHub. It's an application that is, not surprisingly, written to be able to deploy to Anthos, and it consists of a bunch of microservices. So there are 5 microservices. You have a user service written in Python, and then you have the ledger services that are written in Java and Spring that mimic a bank interface. Okay, so the application as it's written on GitHub, it uses Postgres as its database, but because YugabyteDB supports the Postgres protocol, what I've done in this demo is I've changed the connection strings to point to YugabyteDB deployed in Anthos instead of Postgres. So I didn't modify the application at all. I just changed the connection strings. That's all I did. So in order to achieve this, I've got 3 GKE clusters, one in East Coast, one on West Coast, and one in Central. They're all talking to each other. And so I've got a total of 6 pods running across 6 nodes total. And this gives me the resilience, high availability, and scalability to survive failure. So let me share my screen and I'll actually show you what this looks like.
Right. And then, Jake, just wanted to add one point that even in an event of a disaster that we end up losing any of the Google Anthos clusters and any of these topologies here, Yugabyte as a service remains resilient to that failure. That is,
Right.
Yugabyte can actually afford to lose one entire data center in an RF3 deployment that you folks see here, guaranteeing that there will be no data loss. And in terms of RPO, it's zero. In terms of RTO and Yugabyte, the time it takes for us to rebalance that traffic and get back to the other two regions is about 3 seconds. And that is one of the core fundamental design principles in Yugabyte. That is, we ensure you that Yugabyte will never have a downtime when you have a disaster of any of your regions in your topology.
Let me show you the Anthos console here. So over on the left-hand side, I have the Anthos console that consists of the 3 Kubernetes clusters that I brought into management. So I created these clusters. There's one in Central, one East Coast, one West Coast. And I brought them into the Anthos console here so that they're essentially under management via Anthos. So that's what it looks like from the Google Cloud Platform side. From the Yugabyte Platform side, so let me show you what this looks like from Yugabyte Platform. So Yugabyte Platform is the management interface to deploy and manage the Yugabyte databases in whatever provider you have. So you can see across the top there, there's a bunch of them, but today I'm going to focus on the Kubernetes one, and I've defined a service, a cloud provider. It's kind of like a virtual container, if you will. I called it Anthos, and it consists of these 3 Kubernetes clusters that I created. So I took the kube configs from each one of those clusters, plugged them into this user interface, and now I've got this deployment target that I can use to create a database on. So I've already created one of those databases. Now I created what's called a universe. So you can see here I've got a universe, which is, you can think of it as a geo-distributed cluster of YugabyteDB. I called it Anthos 3 regions. So if I go in here, I can see, okay, I've created this database. So this is the database that this web application, this bank of Anthos, is actually running on. Okay, so you have tabs here where you can look at things like metrics. We give you all the stuff that you would expect from a database management platform, ops per second, latency, CPU, all that kind of stuff is available here in the metrics, and you can alert on all this stuff as well. So this is what it looks like from a database perspective. So from an application perspective, what I'm going to do is I'm going to log into 2 different screens here. So over on the left, I'm going to log in as test user. And this is what the Bank of Anthos application looks like when you log in. So it's a ledger. I can deposit, I can transfer, it's got a balance, that sort of thing. And I'm going to log in as a different user over on the right. So I've picked a user called Eve, and I'll log in over here on the right. So I've got 2 different browser windows, 2 different accounts. So the first thing that I'll do is I'll go ahead and I'll deposit some funds here. So let's say I'm going to deposit $100 into my account. I click deposit. So this web application is submitting the transaction to YugabyteDB. You can see here my account got credited by $100. So now I'm going to send, let's say I send that $100 to Eve. I select Eve as my recipient. I click 100, and then it submits that transaction. I go over here to Eve's window and I click refresh. And after her screen refreshes, you can see that she's received the $100, and mine has been debited by 100. So this is demonstrating database transactions that are occurring in this web app. Normal business as usual. There's no interruptions of service or anything like that. So what I'm going to do now is I'm actually going to take the West Coast offline. I have a script that does that. You'll remember I had that haiku that talked about how funny or how important DNS is. And the reason why is what I'm doing right now is I'm altering the DNS service so that the DNS servers cannot resolve. If I'm in the West Coast, I can't resolve the other 2 regions. And if I'm in the East Coast, I can't resolve the West Coast. So the Central and East can still talk to each other, but now the West is being taken offline. So what I'll do is I'll go over here and I'll look at the pods that I've defined. It takes about a minute for this liveness check to show, but eventually I'll refresh this enough and you'll see that the West Coast will go offline. So while we're waiting for that, I want to show you how easy it is to change or scale your database deployment. So in this case, you can see here, I've got my configuration consisting of a provider called Anthos. I've deployed it across 3 regions. If I wanted to increase the number of pods, I could just click buttons here, add nodes, make changes to the universe, as we call it, and deploy those. And that's how I can do my scaling in YugabyteDB. So let's go back and see if my my pods are offline yet. So this takes about a minute. Okay, so the first one you can see there at the bottom there, it says the bottom one is unreachable and that other one in the west should be unreachable. Okay, so now they're both unreachable. So the two west pods are now unreachable because that cluster cannot resolve DNS to any of its peers. Okay, so effectively the west is now offline. So what I'm going to do now is I'm going to go back here and I'm going to do the same thing I just did. So let's do $500 deposit. All right. So there's my $500 deposit. Now I'm going to send payment to Eve again. Let's give her $500 as well. All right, and I go over to Eve, and when I refresh her screen, you can see that her balance has increased by 500 and mine has been debited by 500. So in the face of a complete regional outage, YugabyteDB is resilient enough so this web application keeps on going, doesn't throw any exceptions to the user. It just keeps on going as if everything's okay. And because I've got two surviving clusters, I can still do my distributed transactions just fine. Anything else?
This is great, Jake. Thank you. Thank you for doing this demo. And then folks, as you saw, Yugabyte was resilient, as Jake mentioned, to a complete region or a cluster failure, in this case of Google Anthos. And the transactions keep working, the applications keep working. So this is the power of resilience and HA and scalability, actually, that is built into YugabyteDB as a distributed SQL database. And we would want all of you to embrace this so that you can focus on writing your business applications and logic without having to worry about the hard work that goes inside the databases itself. So thank you, folks. We hope you loved our demo. Please send us your comments or links to any of the few ideas you have on our YouTube or any Vimeo channels here. Thank you.